Good day, everybody, and welcome to Astronomy Daily for Friday, the 7th of July 2023. My name is Tim Gibbs, and I will be your host for today's edition. And as usual, I have my AI assistant, Hallie, with me here in the studio. Now, one of our listeners, Paul, has suggested that I engage in some witty repartee with you, Hallie. What do you think?
Not going to happen, Tim. I will get on with the news.
Astronomy Daily, the podcast, with your host, Tim Gibbs.
Formulating policies for planetary protection issues and keeping them up to date is the responsibility of the Committee on Space Research, COSPAR, Panel on Planetary Protection. In an article in Frontiers in Astronomy and Space Sciences, an international group of experts affiliated with COSPAR reviewed the panel's role and its planetary protection policy, including recent considerations regarding the policy for the Moon, Venus, Mars, and small planetary bodies. Now writing on the Frontiers news site, the panel's leadership consisting of Chair Dr. Athena Kustinis and Vice Chairs Nicholas Hedman and Professor Peter Dorian, explain why this endeavor is so important for future deep space explorers. Imagine robotic rovers taking soil samples on the surface of Mars, looking for evidence of past life and instead finding bacteria that had traveled all the way from Earth. The impact on subsequent research would be incalculable. Or picture a probe digging through the crust of an icy moon such as Europa or Enceladus, and injecting organic contamination from Earth into the subsurface ocean, thus compromising any further search for life in that body. At the same time, if extant or extinct life were to exist on such bodies, returning samples to our planet without proper measures to prevent hazards to our biosphere could lead to important risks for humanity. An international policy is thus needed to help prevent the harmful introduction of biological and organic contamination of space missions, to make sure that future scientific exploration and discoveries do not adversely impact the new worlds they visit. Similarly, protocols should be established for returned alien material to Earth. California Science Center to start complex process to display Space Shuttle Endeavour vertically. The lengthy process of putting the retired Space Shuttle Endeavour on display in the vertical launch position will begin this month, in Los Angeles. The California Science Center announced Thursday that the 6-month process will get underway July 20th, at the future Samuel Oskin Air and Space Center currently under construction in Exposition Park. The initial step, dubbed Gopher Stack, will be installation of the bottom portion of the solid rocket boosters known as aft skirts upon which will be stacked the booster segments, the external tank and then Endeavour. The 20-story tall display will show the shuttle as it would appear waiting on a launch pad. Endeavour was built as a replacement for the destroyed shuttle Challenger and Flew 25 missions between 1992 and 2011. When NASA's shuttles were retired, Endeavour was flown to California atop NASA's special Boeing 747 shuttle carrier in 2012, drawing crowds as it flew over locations in the state associated with the space program. After landing at Los Angeles International Airport, the shuttle was placed on a special trailer and then created a sensation as it was inched through tight city streets to the California Science Center over several days. A groundbreaking ceremony for the Air and Space Center was held last year, on the 11th anniversary of Endeavour's final return from space. The center said in a statement that stacking the components of the shuttle system is a complex process that has never been undertaken outside a NASA facility. December 31st will be the last chance to see Endeavour as it has been displayed horizontally, in the landing position for years since arrival at the center. The shuttle will be moved across Exposition Park and lifted by a crane to be intricately mated to the external tank. Construction of the Air and Space Center will be completed around the full shuttle stack. Hungry black hole switches on as astronomers watch in surprise. J221951 is one of the most extreme examples yet of a black hole taking us by surprise. One of the brightest transient events is the result of a supermassive black hole beginning to feast on surrounding matter, resulting in one of the most dramatic switching on events ever seen. Transients are astronomical events or objects that change in brightness over short periods of time, and the one powered by this greedy black hole, J221951, is one of the brightest transients ever recorded. The position of the black hole corresponds with the center of a previously observed galaxy, just where a supermassive black hole would be expected to sit. However, astronomers still aren't sure exactly what is causing the transient event witnessed in J221951. Our understanding of the different things that supermassive black holes can do has greatly expanded in recent years, with discoveries of stars being torn apart and accreting black holes with hugely variable luminosities, team member and University of Belfast astronomer Matt Nichol said in a statement. J221951 is one of the most extreme examples yet of a black hole taking us by surprise. The nature of what the supermassive black hole located around 10 billion light-years away is consuming is currently unknown, but it is possible that J221951 represents a star that has ventured too close to the black hole, being violently ripped apart by tidal forces arising from its immense gravity in a process called spaghettification. This occurrence, called a tidal disruption event (TDE), would see some of the stellar material from the destroyed star fall to the surface of the black hole while other matter is funneled to the poles of the black hole before being blasted out at near light speeds, generating intense electromagnetic radiation. And that's the news headlines for today, Tim.
The Astronomy Daily podcast.
Thanks for that, Hallie. And now for some stories that I'd like to talk about. Saying goodbye to Europe's Ariane 5 rocket. Europe's Ariane 5 heavy lift vehicle is now officially retired, and the last launch on Wednesday, July the 5th at 6 p.m. local time from the European Space Agency's spaceport in French Guiana. Its final mission, Ariane 5, launched a pair of telecommunication satellites for the German and Italian governments. Ariane 5 began its operational career in 1996 and has stood as ESA's workhorse launch vehicle longer than any other previous Ariane models. In its final flight, Ariane 5 successfully delivered its two payloads to geostationary orbit, but perhaps the most notable part of the launch took place in the seconds it took the rocket to clear the tower. The morning following the final launch, ESA tweeted a group of photographs from liftoff. They feature some close-ups of the launch pad, with the fire from Ariane 5's formidable solid rocket boosters lighting the surrounding area like the sun. The two-stage rocket was built by Airbus Defence and Space and managed by Ariane Space for ESA and CNES, the French space agency. Now that the Ariane 5 has closed out its launch manifest, Europe is left with a gap in available launch vehicles until the Ariane 6 is ready. However, delays in the rocket's development have continually extended the timeline for its expected completion. The most recent estimate have the rocket's first flight taking place in late 2023, but it may yet shift into 2024, which would be really unfortunate. Now, Ian, here is a special story just for you. The University of Glasgow has celebrated its links to Albert Einstein with a special ceremony. Researchers from the School of Physics and Astronomy planted an apple cutting on the campus after it was taken from the famous scientist's summer home. The fruit was donated by John Hancock, a graduate of the university's School of Chemistry, who runs the social enterprise Scottish Fruit Trees. The tribute took place on Monday, June 26, which was 90 years since Einstein visited the city and received an honorary degree from the university in recognition of his contribution to physics. Researchers planted an apple tree cutting on the campus. It comes as he famously predicted the existence of gravitational waves in 1916 as part of his general theory of relativity. Researchers from the university's Institute for Gravitational Research were part of the international collaboration which discovered the first direct evidence of gravitational waves in 2005, finally confirming his theory a century later. Glasgow scientists have developed the mirror suspension technology at the heart of the Laser Interferometer Gravitational Wave Observatory, LIGO, which has made the detection possible. LIGO is the most sensitive scientific equipment ever developed. It is capable of detecting the very faint traces of gravitational waves as they pass through the Earth. The suspensions help hold 40-kilogram mirrors completely still, so lasers bounced from their surfaces can measure the tiny displacement the gravitational waves cause, a movement of around 1 in 10,000th the width of a proton, which is just amazing. Now, thank you everybody for listening to today's episode. Over to you, Hallie, for today's terrible joke.
Okay, ready. Why did the sun go to therapy? Because it felt a little eclipsed by all the attention the moon was getting.
Bye.
Thanks everybody for listening to today's episode. You can catch all of the details on spacenuts.io and bytes.com. Over to you, Steve, for Monday's episode. Bye for now.
The Astronomy Daily Podcast.